matrix. So we can just go over PHI. So that this is the matrix that we are looking at. Now to get determinant, I'm going to denote a determinant by letter D. To get determinant, we'll take this first item there in the first column, first row, A times its minus, the minus, if we take A, we will now delete 1 and column 1, so its minus will be E F, then we have HI as its minus, then we have minus B. Again, we get the minus of B, so we delete the second column and the first row, so the minus will be E. Then we have F, G, sorry about my handwriting, and I, then plus C. Again, we get the minus, so we delete row 1 and column 3, so the minus there will be D, E, G, and then H. So when we expound on this now, then we should be able to get the determinant of this matrix that we have here. I hope you can still remember that, because when you are getting the determinant, you seem like for this first minor here, you multiply E by I, then minus the product of H times F. And then now whatever you'll get here, you'll multiply it by an A. So that is how we were getting the determinant of a matrix, a 3 by 3 matrix in our case. Now, when we come now to a linear system, assuming that we have been given a linear system, so we can put that down. Assuming that we have A1, a linear system, A1 X plus B1 Y then plus C1, that is in the first row, Z, then we can equate this to D1, then we have A2 X plus B2 Y plus C3, sorry, not 3, but C2 Z, then this we equate to D2. Then the third row now, A3 X plus B3 Y plus C3 Z, Then we equate this to D3. So assuming that we have such a linear system, so remember this first column, the first column there will be our X column, So all the values there are involving X. Then we have the Y column there, Y column, C, so I'll note it with a C. Then we have the Z column, and lastly this last column here, that is the constant column, because it is constant column. It is not dependent on either of the variables, all the variables. So this is a constant column. So assuming that is what we have, now when we label each of the four matrices that we can get here from just this simple the column here, what we'll have is that the first matrix will be the one that is having the values A1, A2, A3, B1, B2, B3, C1, C2, C3. So we can denote that by matrix B. So we can denote that by matrix B. So we can note it down there. B, A1, A2, A3. Then we have B1, B2, B3. So please, if I'm fast, you can say C1 so that we go together. C2, lastly C3. So that will be our matrix D. That is our matrix D. So our matrix D is also known as the coefficient matrix. So this we can call it coefficient matrix. Coefficient matrix. Coefficient matrix. So I'll just call it coefficient M. So then we need to identify the next matrix, which will be X matrix. Our next matrix will be X matrix. So that one we can note it by dx. X matrix, we note it by dx. So dx will be equal to, now we can go back to the coefficient matrix. If we go back to the coefficient matrix, so this should be the values that we have on X. So to get dx, we will use the coefficient matrix, but we will only replace the X column. The first column which has got the x values, we replace it with the values in the constant column. The values in the constant column. I hope we are together. So what we have said is that to get dx, now instead of having a1, a2, a3, now we'll replace those values by d1, d2, and d3. So we can move to that slide. So the first column is what will change. So instead of having a1, a2, a3, a3, we'll now have d1, the values in the constant column, d2, and d3. The other values will remain the same. So we'll have b1, b2, b3, c1, c2, c3. So that will be dx, the x matrix. Then we move to the same way we move to the y matrix. Again, in the y matrix, it is only the coefficient of y that will change. So if we move to the y matrix, now we'll get dy, dy. So the other values will be the same. So we'll still have a1, a2, so sorry about that. Betty, mute your microphone. Okay. Now I was saying that we can move on. So this is a3. Then now the coefficient, the coefficient now in the second column, column y, maybe we can call it column y. So that is what will now change with the variables in the constant matrix. So here we'll have d1, d2, and d3. The other value will remain the same, c1, c2, and c3. Okay. Then we move to the z, coefficient of z. So that will be dz. Again, we do the same operation. So the other values will be the same, a1, a2, a3. Then we'll also have b1, b2, b3. But now the z coefficient, that one is what will change with the constant d1, d2, and d3. So I hope all of us are okay with the way we've got the Y mat. This one now will be Z matrix, sorry, Z matrix. So we have 4, we have the D matrix, the X matrix, Y matrix, and Z matrix. So that is the first operation that we'll have. Now, for us to solve, remember we are using the Kramer's rule to solve the linear system, meaning that we are expected to get the value of X, the value of Y, and the value of Z. We are supposed to get the value of X, Y, and Z. Now, to solve the value of X, now X will be equal to, so we can know that X is equals to dx over X is equals to dx over dx over d, and we are taking the absolute values. I think by now we know what absolute values are. So the absolute value of dx over the absolute value of d. So this is equal to, so that is equal to, now dx will have now d1, the values that we had there, d2, d3, then b1, b2, b3, c1, all the way up to c3, so that we don't take much time. Then we divide this by now the absolute value of d, or the determinant of d, which is just the normal coefficient a1 to a3, then b1 to b3, c1 to c3. So that is how we'll get x. Remember, we have already shown you how to get dx, dy, and dz. We also have the value of d. So when it comes to the value of y, we'll just take dy over d. When it comes to the value of z, we'll take dz over d. And that is what will give us the coefficient. So what I want us to do is to look at an example, and so that we can now work it out without working with the numbers that we are giving, the A, B, and C. So assume that we are having a matrix in the form, okay, assume that we are having a matrix in the form, not a matrix, but a simultaneous linear system in the form x plus 2y, x plus 2y plus 3z. Then we are equating this to minus 5. Then we have 3x plus y minus 3z. This we are equating it to 4 Then the third one, we are having negative 3x plus 4y plus 7z. So these we equate to 7. So assuming that this is what we have, so if this is what we have, then we can get we are told to solve for the equation. So we are expected to get the value of x, the value of y, and the value of z, but we are strictly told to use the Kramer's rule. The Kramer's rule. So remember, we have said that in the Kramer's rule, x will be given by dx over dy will be given by dy over d, and then z is given by dz divided by d. So it is now incumbent upon us to now know the d. The d, now we can get the matrix from here. So that will be 1, 2, 3. We have 3 there. 1, negative 3. Then we have minus 3, 4, 7. So that we can get from this matrix here. Then xy, xyz. Then we equate this to now minus 5, 4, and 7. So that is what we have. So our D will be this matrix here. This will be our D. I hope I'm clear. If there is any clarification that you want, maybe you can inform me. So that is our D, and we can repeat it here. Our D will now be given by 1, 2, 3, then 3, 1, negative 3. Lastly, negative 3, 4, 7. So that is our D. Now we need also to get our dx. So we only changing the first column there. Only changing the first column. So that will be negative 5, 4, 7. Then the others are the same. So 2, 1, 4, and 3, negative 3, 7. That will be our dx. Then we move to dy. So dy again, the second column will change. So we'll have the first one, 1, 3, -3. Then the second column now, that is where we will replace it with a constant column, 5, 4, 7. The last one will be 3, -3, 7. Then we have dz. So maybe I can write it here. dz, again, only the last column, the z column will change. So we'll have 1, 3, -3. Then we have 2, 1, 4. This is 3. Sorry, not 3, but that will now be -5 because that is what is changing. So please take note of that. -5, 4, 7. So what I want us to do is to get the determinant of this d, the determinant of dx, the determinant of dy, and the determinant of dz. So maybe one person can be the determinant of d, the other person determinant of dx, the other person the determinant of dy, and the determinant of dz, so that we don't take a lot of time. So please, can you confirm the determinants? Just like the other ways that we were getting the determinants of a 3 by 3 matrix, we use the same method. So that we take a shorter time and we are able to look for. Okay, I'm told dx is not okay. Okay, dx, Mutoro. This is d. Oh, in dx I wrote 7 instead of 1. Okay, well, Mutoro, maybe you can. That is the d is okay. Or I'm told the last column for dx. The last column for dx, this is supposed to be 3, -3, 7. Look at the first one. We have it. The last column is 3, -3, 7. Yes, Mutoro? Oh, I'm told it is dy. Now dy should be 1, 3, -3. Okay, let me confirm it. We can confirm that. Okay, dy we have 1, 3, -3, then -5, 4, 7. Where is the problem? Yes, Mutoro? Okay, thank you. Now you have seen, okay. So can we get the determinants of d? Now maybe to do this, we'll have 1 into now 7 times 1, which is 7. with practice, you can be able to get this without even writing. Then minus 12. Then we subtract 2, and it's minus again 7 times 3, which is 21. So please, I hope you are doing the others. Minus now 3, negative 3 times negative 3, which is 9. Then plus now 3 into now 4 times 3, which is 12, minus negative 3 times 1, that is negative 3. So please, can you confirm that? So that should come to D should come to 40. This should come to 40. Confirm, because this is 19. So kindly confirm that, and then you tell me the others. Yes, it is 40. So that is 40. Then the one for dx, so dx, again, if you do your calculation well, this should come to minus 40. Minus 40. Then the one for dy, dy is also 40. And then dz, this should come to minus 80. So please, you confirm that. So d is 40, dx is minus 40, dy is 40, and dz is negative 80, which you can confirm. Now to get x now will be equal to dx over d. So in our case, now dx, we've found dx as minus 40, and we're dividing it by d, which is also 40. So our x now will be negative 1. Then we go to y. Y is given by dy. dy divided by d. So if we go back to the other slide, dy is 40 again. So we'll have 40 divided by d, which is 40. So meaning that y will be 1. Then lastly, z. This will be given by dz divided by d. So this will be negative 80 over 40. Therefore, z will be minus 2. So that is how we can use the Kramer's rule to solve an equation. So we use the same concept whether it is a 2 by 2 matrix or even a 3 by 3 matrix. So any question concerning the example that we have looked at? Any question? Any question, members? Or any area that you want me to clarify so that we move together? Okay, I can go back to the how we can find the determinant of D. I think we can do it together so that I can be able to answer Irene, determinant of D. So maybe we can move to the next slide. So we have D given by 1, 2, in the first row. Then we have 3, 1, negative 3. Then lastly, negative 3, 4, 7. So that is what we have. And we want to find its determinant. Now when we are looking for the determinant of this matrix here, so we'll take the first value there, which is 1, 1, and then we find its minus. So maybe before I bring out this, we'll first of all have 1, and then we bring its minus. So we will delete the first row, and we also delete the first column where the value is appearing. So we'll have its minus as 1, negative 3, 4, and 7. Then minus, so remember this is 3, sorry. Minus, then we move to this value there, 2. So we have a 2 there. Then it's minus, so we'll delete the second column and we delete the first row. So it's minus are 3, negative 3, then negative 3 there, and 7. Then plus, now we bring in the 3 there, 3. Its minus will now be, we delete the first row and the last column. So the minus are 3, 1, negative 3, 4. Yes, that's what we have. So if we are expanding what we have here, we'll have 1 into, now 7 times 1 is 7. Then minus 4 times negative 3, that will be negative 12. Then minus 2 into 7 times 3, which is 21, minus negative 3 times negative 3. A negative times a negative becomes a plus, so that will be plus 9. Then plus 3 into 4 times 3, that is 12, minus negative 3 times 1, that is negative 3. Then we expand our brackets. So a minus and a minus here becomes a plus. So we'll have 1 times 7 plus 12, which is 19. So that will be 19. Then we have 21 minus 9. That becomes a 12. So 12 times negative 2. That will be negative 24. And then we have this last one. Now in this bracket here, a minus and a minus becomes a plus. So 12 plus 3, that is 15. 15 multiplied by positive 3, that will be positive 45. So if that is the case, if we collect the like terms, you can start by having 19 minus 24, that is negative 5. Then we add to positive 45. So the sum there will be 40. So I hope that Irene, we are now okay, and also Sharmake Mohammed. I hope we are okay with D, the determinant of matrix D. So Irene, have you been answered? And okay, thank you. And what about Shamake? Are you okay? Okay. Okay, thank you. Now we can move to the one for DX so that we also answer Okemwa Nyambega. Now for X. Okay. For X so that we answer Okemwa. So again in matrix X, we can, that is negative 5, 4, 7. As the elements in the constant, then 2, 1, 4. So we have 2 there, 1, 4. And the last column we have 3, negative 3, 7. So again we follow the same procedure. So first of all we can get the minus of the matrices. So we'll have a negative 5. Now it's minus. Now we'll delete row 1 and we delete column 1. So we'll have 1, 4, negative 3, 7, minus 2. Then we also bring it minus, so we'll delete row 1 and column 2. So we'll have 4, 7 minus 3, 7. Then lastly, now plus 3, and it is this 3 here. So we'll delete this column here and the row where it is appearing. Then we'll have a 4 there. 1, 7, 4. Again, we follow the same procedure. So this will be equals to minus 5 into now 7 times 1. That will be 7 minus 4 times negative 3. So minus 12. Okay. Then minus 2 into 7 times 4. 7 times 4. That is 28. 28 minus, so these are 2 here, these are 2, minus 7 times negative 3, that is minus 21, plus now 3 into 4 times 4, which is 16, sorry, 16 minus 7 times 1, which is 7. Then you have to expand. So if we are expanding that, we'll have a negative 5 into, now a minus and a minus becomes a plus. So that will be 19. Just work it out that way. Then minus 2 into, now again a minus and a minus here becomes a plus. So that is positive 49 plus now 3 into 16 minus 7, that will be 9. So we expand. 5, negative 5 times 19, that will be 95, a negative 95, minus now negative 2 times 49. So what will that give us? Negative 2 times 49, that will be negative 98. Is it okay? Yes. Yeah, that is negative 98. Then plus 21. So can we get this, please? 95 minus 98. You add them because they are both negatives. Yes. $98, we can just add them. 98 plus 95. I hope we are correct in our way. 7 there minus that. Okay. 5, 1, 4, negative 3, 7. Then minus 2 there. We had 4. 7, negative 3, 7, that is okay, plus 3, therefore 7, 1. Okay, we are correct. So this will be 3 here. Then this is 193. So this will be negative 193 plus 21. Yes. Is it 166, Nyagaya? Can you check? This should not be 166. Yes, okay, Mwa? Yes? Get you. Okay, 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 okay. 3 times 9 is 27, yes. So which one are you? Oh, okay, okay. Sorry. This is 27 here. And then can you check this? Can we check the other slide where we had the constant, where we had the constant? Okay. Now this is where the problem is, where here we are supposed to have a minus 7, if I'm not wrong. Let me check. Let me check in the problem again. So if that is a 27, if you subtract it from the others, what will we get? In the problem we have a minus 7. Negative 166. No, I'm saying in the problem we have, let me check where the problem is. Okay. I'm saying here we are supposed to have a minus 7, sorry. A minus 7 there in the constant. So this should be minus 7. So that is where our problem comes in. So where is it? Sorry, where is it? Okay. So I'm saying this one should be a minus 7 here, the value here. So can we find where that value should be? So this is 4. This one should be a minus 7 there. Then when we come to the last one, 3, so this should also be a minus 7. Yes. So if we do this now, then maybe we can cross this. So we'll have minus 5. We can just work it out faster. We'll have a minus 5 there into now 7 times 1, which is 7. That is 7 minus now 4 times negative 12. That is minus 12. So that is 7 plus 12, which will be 19. So this will be okay. Then now we'll have a minus 2. But now we'll have 7 times 4, which is 28 there. Then minus now negative 7 times negative 3, which becomes a positive 21. So 28 minus 21 will have a 7. So 2 into 7 there, plus now the last one, 3. Now here we'll have 4 times 4, which is 16, minus now negative 7 times 1, that is minus 7. So this becomes now 3 into 20. 16 plus 7 is 23. You can confirm that. Now this will now be negative 95. Negative 95. Then here we'll have negative 2 times 7, which is minus 14. And then 3 times 23, that will be plus 69. So what will this give us? So negative 95 plus, if we subtract negative 14 from it, that will be minus 109. Minus 109. Then we are adding to 69. So if you add that, now you'll get a negative 40. So thank you, Okemwa, for that. I hope we are now okay. Any other question? Any other questions so that we are clear? Yes? So please, to use the Kramer's rule, we need to know how to get a 2 by 2 matrix, the determinant of a 2 by 2 matrix, and also the determinant of a 3 by 3 matrix. So actually this is a shorter way of solving the matrix equations other than using the concept of the minors, the adjudicates, and so on. So this is a bit easier, and remember, practice makes perfect. So if you practice, then you will find your work will be a bit easier. So any question up to that point? Any question up to that point? Or any clarification? Okay, if there is no clarification, then I think we can move to our discussion forum and look at the question that I've posted there. And please, I urge everyone to participate, because it is through doing the practice that we will learn this concept better. So I thank you for today, because I'm ending the live session and we are moving to the discussion forum. So thank you for today, and may God bless you. Thank you.